receiver end, I need to send. This is how the communication happen. So from here the data is sent and here it is reached the destination. So this is talk about syntax, the data formats, the signal levels, everything. So how you are sending you are sending in zeros and ones, how you are sending the data. So that is very, very important, the data formats. Fresh is sending a message to me. You can see it here. Yes, I can show it to you. So Reliance Fresh is sending a message to me. So like they sent a message. Can you see? You can't see the number. You can't see. Computers are interconnected. On what basis is interconnected is called as topology. Let's move on to the next one. So this is called as ring topology. Let's move on to the tree topology. As I told you, there is a main switch. From there you are able to see the multiple switches are coming down. Today morning I spoke with one of my friend. So his name is Praveen, and I got my friend Jayant. Okay, so we started talking, we started chatting, and we started talking to them. So why are they wired? Yeah, it's a huge distance I covered. It comes here, class B, and it will have these two for network and this two for host. And if it is this number starts, if this number starts with this now is of this number, it is a 48-bit number. The kind of a light signals is called as fiber optics. So it will have the core layer in the mid. Hi, this is Venkat from Wikitech and Kashi Infotech. After so many days, I'm going to talk about a great thing. Today, I'm going to talk about what is networking and the networking tutorial. So we'll see all kind of concepts here today. Like I'm going to talk about the networking concepts. So before that, my channel name is Wikitech, and if you missed any of my technical videos, these are some of my videos. If you missed any of things, just go to my YouTube channel, Wikitech. So we got two channels, Wikitech and Kashu Venkat. Okay, so if you love this channel, please subscribe it. This is a technological channel, and this is for the subjects, the engineering students and college students subjects are there. So if you love this channel, please subscribe it and click that bell symbol to get regular notification, and I request you people to inform to your friends and everyone. And if you're looking for any other topics, sir, I want this technology, any other technology, please put it in the comment. I'm ready to do it for you. Yes. So it's my Instagram account, and you can contact me. Just click that follow button. You can contact me, send me a message. I'm ready to respond you. And here is my contact numbers to contact me for any queries. Yes, I before going here, a networking tutorial, my technical tutorials are there in wikitech.com/tutorial. Just go there and learn as much as you can. So welcome to the world of networking. So let's move on. What is networking, man? Okay, so this is going to be the real interesting area because I'm a Cisco certified guy. I'm a recognized international certified Cisco networking guy, Cisco certified guy, as a CCNA guy. Anyway, I've done it before itself. Anyway, let's move on to the world of networking. I'll give lots of ideas what I know it. Yeah, I've seen a lot of things practically. I got something for you. Okay, so I got I got the router box. You can see the routers. Yes, I got the extender. I got the network switch. So we are going to see all these stuffs in practical. We are going to see it. So you'll be enjoying my session. You'll be enjoying my session. So you can see all this. Yes. Let's see. Okay, let's see some practical things also today. So before that, my company Kashi Infotech, we are conducting ethical hacking training for the people. Network engineer with ethical hacking, the profile will be awesome. Okay, so I'm giving all this on network system, file servers, all of things. And apart from that, I'm going to give a training on the Linux. So Kali Linux and Parrot operating system is the dedicated operating system for ethical hacking. So I'm going to teach everything. So it's Kashu Infotech certified ethical hacking experts. Okay, so if you're really interested, just contact my number. I'm ready to help you, and I'm the trainer. And Kashu Infotech certified networking specialist. A complete Cisco CCNA concepts, complete networking practicals, basics to advanced networking concepts, and apart from this, I copied and pasted the same here. Okay, so you will get everything in practical. In practical, I'm going to teach you. So if you're really interested, you can contact me. Just come down to my office. Let's connect the computer, make the environment ready. Yes, we'll do it. Let's move on. So what is a network? What is a network? A network is nothing but, see, I want to create a LAN. I want to create a LAN. I want to create a network in my company. So obviously you got the CPU box. So I'm not sure whether I can grab this box. Yes, this is my CPU box. Oh my god, it's my CPU box. I got my CPU box here. Okay, I got my CPU box here. Okay, so over there I got my motherboard here. I got my motherboard here. Yes, I got the motherboard here. So the computers over here, you got the computers and everything here. You got the computers here, and this is connected to, so this computer, it's connected. Yes, I got the cable here. This is your computer. This is my motherboard. So this is the computer. Once this computer is connected to the switch like this, you got the switch here. This is the switch. It's not this one. Like here, you got the box and black color box and all. Anyway, like I opened the box to show you the circuits and everything. Okay, so I got this one. It's connected. Okay, so this is my LAN environment. This is my LAN environment. I got the LAN environment ready. So you got the computers. You got the computers connected to the switch. Okay, so this is how they will create a LAN environment. So you got the computers, you got the switch. From the switch, your router is connected. So from the switch, so you got the lights and everything here. You can see the light. So computer is here, your switch is here, and from the switch, you got the router connected. This is the router. This is the router. From there, the external environment will work. Okay, you may ask me a question, sir. In my home, I don't have the switch, sir. So the computers are directly connected to the routers. Yes, you can connect to the routers here. You can see the yellow colors here. You can see the yellow colors here. Okay. So okay, yeah. So the computers are connected to the switch, and the switch is connected to the router in a company environment where we got lots and lots of computers. Sir, I got only 2 or 3 computers. So I got my computer connected directly to the router, no need of switch. So no need of switch. Okay, so this is how the network formed. Okay, so my LAN, my local area network, my office is constructed. Now the data, so from the router we got the like internet world. So it will move on to the internet world now. So I got my friend somewhere sitting. So the sender, I need to send via the internet to the receiver end. Okay, so the receiver end I need to send. This is how the communication happen. So from here the data is sent, and here it is reached the destination. So this is my office, which is in Chennai, and this is my friend's office. He is in Bangalore. So Chennai, I am sending a data. Hey, how are you, man? It is going here. Hey, how are you? Yeah, I am fine. So it is coming here and it is reaching the destination here. This is how the communication is happening between the sender and the receiver, the source and the destination. So this is how the communication is happening. Let's move on. Yes, let's move on to the characteristics of your network. So we are going to talk about, sir, so you just connected the computers and everything with this network devices. What is the characteristics we have to measure? We have to take it up. So that is how I'm going to see it. So if we talk about the network characteristics, I need the speed. How much the data transfer is good, man. So you need the speed. And the cost, it should be cost effective. So instead of this router, can I buy this router, sir? First, now like I need to run this one. Yes. So I got a Geo router here. Okay, so it got a bandwidth of very less, and this one is a hyper speed in Gbps. The router speed is in Gbps. Gigabits per second. Okay, so we have to decide like what is the speed I want and the cost. Very less cost I want. Security is very, very important. So because like others should not access my network. Availability, the routers, the network should be available. Okay, so I'm sending a data, but it's not working. Oh, my internet is down, man. So you should have the availability, scalability. I can increase it. Instead of 5 computers, can I extend it to 10 computers? Yes, you can do it, man. So you can scalability. For that, we need this kind of devices. Yes, this kind of devices. It's called extender. You can extend the device. We are going to see those things later, don't worry. So these are kind of extenders. So you got the scalability, reliability. The network should be reliable. Whatever data I'm sending, the same data should reach the destination. There should not be any change. And topology, how you are designing the network, how the computer should be connected, whether the device in the center, around it you should connect, or how you want the devices should be connected. These are the very, very important characteristics of your network. Now let's talk about what is a protocol. The protocol is nothing but, see, like I'm sending a data. So over here, I got the computer, and via the wire, it is moving to the switch. So something is there here sending the data via the wire. So that is called as protocol. The protocol is nothing but, so it is nothing but the set of rules. The set of rules used to transfer the data from the source to the destination. That is called as protocols. The protocols will have the three key elements. The one is syntax, the other one is semantics, and the other one is timing. If we talk about syntax, the data formats, the signal levels, everything. So how you are sending you are sending in zeros and ones? How you are sending the data? So that is very, very important. The data formats and the signal levels, how much this data is moving out without any problem. So signal levels, that is the one we have to check it out. The second one is semantics, how the data is controlled. So to whom I need to send the data, and apart from that, there should not be any errors. Whatever 10 data you sent, 10 data it should be received. So that is your semantics. And finally, the timing. So what is the speed and what is the sequence you are sending the data? 1, 2, 3, 4, 5. The same 1, 2, 3. The order should be same, man. It should not be 1, 6, 6, 8, 7. No, it should not be there. The order should be same. So these are the three key elements of the which is framed as a program, and this program is called as protocol. Again, the protocol is a needy one to transfer the data from source to destination. Okay, yeah, this is called as protocols. I'm trying to tell you a protocol example. See, two people are talking. This girl is talking to this guy, hi, and he is responding, hi. Got the time? So it's 2 o'clock. So this is how the communication is happening. Okay, so this is the same thing which is happening here. Two computers are there, the TCP connection request is done and TCP connection reply is done, and this guy is sending the website details and this guy is accessing the website. So this is how the communication is happening. This is how the communication is happening. So for this kind of communication is called as protocol. How this communication is happening. So the first thing, say two computers want to talk, so send a TCP request and that guy will reply. So this is a formality, sir. That is a formal. That is called program. That is called protocol. So this is called as protocol. So here is the protocol examples. Sir, my mobile is there, my router is there, and I need to connect to my Wi-Fi, sir. We need a Wi-Fi protocol. I need to send a file to the server, sir. I need to upload my resume, sir, in naukri.com, sir. FTP, file transfer protocol. So I need to send an email, sir. Email protocol. Email protocol can be SMTP, simple mail transfer protocol, or it can be POP3 or POP. It's a post office protocol. Post office protocol is a Wipro question. Don't worry. So it is an interview question. Just learn it. Okay. Now that's our protocol examples. Let's talk about the mode of communication. So what is the mode of communication these networkings are using? So that's the one we are going to see it now. So here is the one I'm going to talk about. So the communication can be a simplex. From one direction, the message is sent to this guy. Okay, and SMS. I'm sending a message to them. Okay, if it is, sir, I'm sending a message and he is responding, sir. Sir, no, I'm getting a message. Usually, I used to get a message. With me. Yes. I can show you. Yeah. Yes, you can see it here. I'm not sure whether you are able to see it here. So Reliance Fresh. So Reliance Fresh is sending a message to me. You can see it here. Yes, I can show it to you. So Reliance Fresh is sending a message to me. So like yes, they sent a message. Can you see? You can't see the number. You can't see the. Yeah. You can't see the number. You can see the number. So it is like a JD or Fresh. I can't respond them. It is a simplex. It is a simplex, so I can't respond them. Okay, so over here, okay, this is my customer care number. You can see it here. Okay, so this is a number. This is a number where I can respond them. Okay, this is becomes a half duplex kind of. Okay, so simplex is nothing but the communication will be sent to them, but they can't respond me a radio signal. So radio, it is receiving, it is coming here, but I can't reply back to the radio, man, because the waves are connected and I'm receiving the radio signals. So that is your simplex. Whereas the half duplex is like, it's walkie-talkie. Oh, you got the picture. Sorry for that. You can see the picture. It's a radio and everything is a TV and everything is here. Okay, so over here, so you got the walkie-talkie. So the police people will be having the walkie-talkies. Over using this walkie-talkies, they are able to talk. So at a shot, one guy can talk and the other guy can listen, and other guy can talk and I can listen. That is called as walkie-talkie. And over here, your full duplex is your friend is fighting with you. So two people communication is happening. Both communication is happening. Okay, that is called as, so simplex only one communication is happening. Half duplex, two communication, but at a shot it's not there. At a shot it's there in full duplex. That is the differences between, that is a mode of communication. Now let's talk about the line configuration. The line configuration, in the sense, it is like we are segregating how the computers are connected. Okay, so this is the line. This is the line. So in a link, the end to end, say a computer is connected to another computer, man. A computer, oh, disturbing me, sorry. So a computer is connected to another computer. Yes, work computer, a server is connected to another computer. The computer is connected to another computer via a link or something like that. Somehow it is directly, the link is directly connected to the end user computer. That is called a point to point. Sir, one line, sir. In this one line, I need to connect multiple computers. Oh, you can connect multiple computers. Huh? That is called as a spatial multi-point. Spatial multi-point. I can send data to everyone. And in the same thing, you will be having time sharing system. At a shot, at this time, this guy can do. Sir, 10 o'clock, this computer should work, sir. 11 o'clock, this computer should work, sir. 12 o'clock. So time sharing. Time sharing. And over here, multi-point, anyone can access. That is another thing. And see, left room guy, first guy, access it, man. Second guy, access it next man. Third guy, access it next man. So time, I don't know, man. Like that is called spatial. Based on the location, access the link. That is the spatial. Based on the timing, if you access the link, that is called time sharing. The same link can be shared by multiple people. That is called multi-point. So this is called as a line configuration. How you are. So I got this one. I got this wire. I got this wire. Only one person is accessing, man. Okay, this is point to point. This is point to point. If you got another computer here, it's point to point, man. So this is how it will be. It is called line configuration. Yes. Now it's an interesting topic I'm going to talk about, that is called as a topology. So we are going to talk about topology, how we are going to construct, how we are constructing the network. So two or more devices connected to a link, two or more links form a topology. Okay, so two or more links form a topology. Now let's talk about the topology. So this is how there is a link and multiple computers are connected, the data is moving on. This is called as a bus. It is called as a bus topology. It is called as bus topology. Over here we got a closed connection, a ring, a closed loop, that is called as a ring topology. We got the ring topology. The other one is like you got the switch or hub in the mid. You got the switch hub in the mid, and via this one the computers are connected. That is called as star topology. So this is called as star topology. Over here you got the network devices like the routers and the switches are here. From there the computers are connected like this. It is called as hybrid or tree topology. This is called as a tree topology. From here, every computers are interconnected to other computers like this, and this is called as mesh topology. So it's called as mesh topology. And here is the final one. You can have all these kind of networks. You can have like a hierarchy one. You got your bus topology. You got a ring topology. Everything is connected, man. That is called as hybrid topology. So these are all different. So how your computers are interconnected, on what basis is interconnected, is called as topology. Let's move on to the next one. So here is your bus topology. So as I told you, so it is simple to install and it is cheap to install. Less cable is used to compare to any other topology. So these are the things available. If main cable is damaged, the main cable is damaged, so there is a damage happened here, over here. So obviously the whole network is failed. The whole network failed. So this guy can't access this guy if main cable is disconnected. As more workstations are connected to the network performance very slow, because I got some 100 computers, sir. So from here, even it will reach the 100th computer. It's slow, man. Every workstation can access all the data in the networks. So you can see, this guy is sending the data to this guy, but this guy is accessing here. Security problem is there. So that is the biggest problem in bus topology. And here is the next one called a ring topology. So over here, the advantage is very cheaper. The data flows around the network too, so it is very fast. And there is no reliance on the central computer. So there is nothing like that. It's a central computer is there. Go to that computer and use it. But obviously, what is the disadvantage? If the network is broken here, then it's a problem. Sir, I want to connect this guy to this guy, sir. I need to go a long way to reach this guy, sir. Can I have this guy short, sir? So this is the drawback of ring topology. So if it is broken, it's a problem like a bus topology. So nearby guy also, like the ring should be formed. The ring should be formed. So this guy can't directly access this guy. Via this guy is accessing. And security is also a big problem. So this is called as ring topology. Let's move on to the tree topology. As I told you, there is a main switch. From there, you are able to see the multiple switches are coming down. Okay, this is how the tree topologies are. The extension of bus and star topologies. So this is a typical extension of bus and star topologies. Expansion of node is possible in easy way. You can expand the nodes. You can have multiple computers in the bottom. That's good, man. That's good. Easily managed and maintained. So we can easily manage and maintain the things. That's good. Okay, error detection is easy. So we can find the error. Hey, where is the problem, man? I can easily find the errors. That is the advantage of tree topology. So the disadvantage is like it is heavily cabled, lot of wires, man. Investment cost is more. So costly. If more nodes are added, maintenance becomes very difficult. It is lot of computers connected like this. Maintenance is tough. So if the central hub, if this guy failed, gone. If this guy gone, nothing will work, man. This is the biggest problem in tree topology. Okay, so let's move on to the next one. And here is the star topology. So each device has a dedicated point-to-point link to the central controller, usually called a hub or a switch. So this is how the network is formed. So in our companies and all, so you can see the switch. You can see the switch here. You can see the switch here. Over here, you got 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 2, 16 switches are there. So one input, I can connect 15 computers here with the switch. I can connect 15 computers with this switch. So that's how. So usually the company environment will have this kind of strategy, the star topology, a fast performance with a few nodes and low network traffic, very fast. Hub can be upgraded. Instead of hub, I need a switch. You can do it. You may ask me what is hub. Don't worry, I'll teach you. Don't worry. Okay, so easy to troubleshoot, easy to set up and modify when the node is affected. So if this node is affected, we can have the rest of things working. One computer is repaired, no problem, man. No problem. So that is the advantage of this network. And cost of installation is high because we need to buy this hardware and everything. But this is advisable mode. Star topology is advisable mode. Expensive to use. If the hub fails, if the center guy, if the switch is working, not working, then gone, man. No network. That is the biggest problem. So if the hub is failed, gone. The performance is based on the hub. So this is very, very important. We should have, see, you can see, if I got this kind of devices, instead of this device, you should buy this device, because this one is in Mbps and this one is Gbps. Okay, so you have to find a device which is really like a faster. So the entire network is faster based on the network device which you are connecting. Now here is a mesh topology or complex network, everyone connected to everyone. So it is worst. But there are environment, they will have this kind of mesh topology also. So each connection can carry its own data and load. So every connection, so sir, I want to send a data to this guy, sir. I can have the concept, sir, dedicated connection. Why should I go from here to here to here, sir? No, I don't want that, sir. So it is robust. Fault is easily diagnosed because I can find this link is problem. This link I can find easily, man. Provide security and privacy. Superb security. Because the data from this guy will go only to this guy. It won't go via this guy. It won't go. So that's the advantage. And but the installation configuration is very, very tougher, costly, real costly. Bulk wiring is very, very required. So it's a real mesh. A mesh is real mess. Anyway, so now let's talk about the hybrid topology. Hybrid topology is very, very different. So reliable as error detecting and troubleshooting, as I told you. Hybrid is a combination of all these stuffs. Okay, you will have the ring, you will have the mesh topology, everything. So effective, scalable, flexible, but very complex in designing, and it's costly. Okay, that is why like the hybrid technology is not preferred in most places. Yes, we have seen about the topologies. Yeah, here is a topology. Yeah, you can see the hybrid topology here. This is your hybrid topology. You'll have the star, you got the like a tree, you got the bus, you got the ring, everything. That is called as hybrid topology. Let's talk about the network types. We are going to talk about the network types now. Let's move on. So just give me some 10 seconds. I'll take some water. Yes, let's move on to the network types. So to which distance the data is getting communicated. As I told you, like we got the interview questions here. Like you can use this page to learn as much as you can. So like here is the one. So here is the link to access it. So just go to our website kashuinfotech.com/CCNA training in Chennai. Okay, this is the link over here. Like just go to this link. You are able to see the interview questions here. Just scroll down to the bottom. You are able to see the interview questions. Okay, so just use it and learn as much as you can. So before going to the interview, please use this page to learn the interview questions. Yes, like most of the people, they used to ask me a question, sir, like I need a job, sir. So I got a lot of problems. I need a career change, sir. What I can do? Many people, they don't know what they have to do. I'm a fresher. I got arrears. What can I do? The one thing, the shortcut to go for a job is internship. And Kashu Infotech, our company, we are providing internship to you people. And if you're really interested, you just contact me. We are ready to help. So our company Kashu Infotech, like we are giving lots of 3D animation training. Hope you like enjoy my session today and learn as much as you can. So here is the one, like our company Kashu Infotech, we are providing 3D animated technological courses to the students. So both online and offline. So we got ethical hacking, Python, machine learning and data science, Java, Android, web designing, cloud computing with the AWS, DevOps, big data, and for the mechanical people, we got 3D modeling, AutoCAD designs and SolidWorks, and apart from that, robotics, and we got multiple things like for example, for the electronics people, we got IoT and everything. So the training languages are in English and also in Tamil versions, and it's 100% practical 3D live classes we are giving to you people, and we got 5 days, 10 days, 20 days, 1 month of programs. If you're really interested, here is the link to contact, and I'll give the contact numbers to you. And recently we launched a 4 bundle package courses also. So we got our ethical hacking, Python, machine learning and data science package, and it's like everything. All my courses are cheapest cost with a complete 3D based animation courses, and we'll be giving the certificates and everything. If you're really interested, you just contact us. Many people used to ask me questions, sir, what your company is, what you people are doing, man. So our company, Kashev Infotech, so we are providing career guidance, job guidance. We will guide you. Don't join my company. Call me, treat me as a brother. I'm ready to guide you. Whatever things you want, I'm ready to guide you. And if you're looking for internships, I can help you. In plant training, we are working out mini projects, final year projects, software development, and website creations. So this is how our company is. Let's talk about the network types now. So network types, to which distance the data communication is happening, how much distance the data or communication is covering is the one we are going to see. The first one is LAN. Sir, I got 10 computers, sir, connected with my switch and router, sir. Okay, so you got the computers here. You got the computers here. The computer is connected to the switch and it's connected to the routers and it's connected to the network, internet, my office environment. That's awesome, man. That is my local area network. From there, I got my like a communication happening between the cities. I got my friend in Bangalore. I'm in Chennai. So I want, hey, how are you, man? And we both are communicating. So the communication is happening among the cities, a metropolitan area network. It is like the communication is broadened. It's metropolitan area network. From there, so we got the communications. So my friend, today morning I spoke with one of my friend. So his name is Praveen, and I got my friend Jayant. Okay, so we started talking, we started chatting, and we started talking to them. So why it's a huge distance I covered to talk to my friend. One guy is in UK, the other guy is in US. Okay, so I spoke with them. So that is your wide area network. I'm chatting, I'm communicating with my friends who are in the outside country. That's a wide area network. Yes. Let's talk about the network types further. See, as I told you, like I got the computers here. The computers are connected to like this is my office and it is connected to the metropolitan area network. So I'm communicating with one of my friend. So my friend Shiv Arun is there and this guy is in Bangalore. I need to communicate with that guy. I want to communicate with that guy. So obviously, like in the communication, so from my office, so via the metropolitan area network devices, switching center, so to Bangalore interconnect. So from here to Chennai, it will go to some Hosur. From there, it reach Bangalore. So the communication is happening, man. So the switching centers are there, and it will reach the destination. And my friend is talking to me. The Jack and Mary is talking. So these people are in different places. They are different cities, and they are communicating. So this is how the communication is happening. I got mosquitoes here, man. Yes, over here, as I told you, the communication is happening in an office that is called as a local area network, whereas the communication is happening between the metropolitan cities that is called as metropolitan area network. And if the communication is happening wider, that is called as wide area network. Okay, this is how the network types are. So like a further digging, sir, based on the environment, how the computers are interconnected, can I have the network types? That's where you got an internet where the communication is happening from your computers to the outside environment beyond my office and external public cloud or public places. That is how your internet works. It is public. Large numbers of number of connected devices are there, not owned by anyone. It's public. World Wide Web. It's public, and the information can be shared across the world. Over here, I got the private network, which is my office, man. I got my computers interconnected, and we'll be having the communication so that no one can access my computers from the external world. So that is your private networks. The limited amount of users with access, owned by an organization, information shared within our enterprises. That is your intranet. Sir, I want to communicate with one of my clients, sir. That is where your extranet comes, but it's a private one. I'll be communicating with those people, and it's a private one. It's a virtual private network. Yeah, private network to communicate to the external world, but no one can access it. The outside people, the public can't access it. That's where the extranet comes into the picture. So you got your private VPN or VPN, limited number of access or users to access, owned by one or more organization. Information is shared among the people, among the employees and the external people, maybe my client. So inside the environment intranet, with my friend extranet, okay, with everyone, that is our internet. This is how your segregations are. And here are the differences between the intranet and the extranet. Yes, over here you can see it here. It's private. Organization internally with it is with the other friend also, partners. It will be so communication with the partners. Internal employee communication, telephone diaries, everything, and check the status, accessing the data, sending the email to the client and everything. So the intranet is in my body. I'm eating food. It is to form my body, man. That is your intranet. I'm giving my food to my friend. That's your extranet. My friend, not to someone. That is internet, not to someone. So to my friend. So something like that. So internal employee communications, telephone directories, everything. Check status of the orders and everything here. It is highly secure, configured under 100 security level in firewall. So generally uses VPN technology to have a secure communication with my friend. It is regulated by an organization. It is regulated by myself and my friend, my other organization. Also, it is owned by single person. It is owned by multiple people. So that is the differences between the intranet versus extranet. So I told you about the protocols. If two computers are or you got the two network devices and the communication is happening between these two people can be achieved with a real-time system that is called as protocols. Yes, now let's talk about like I said, this protocol is designed on some model, right? So I'm going to talk about that model that is called as Open System Interconnect model. So I'm going to talk about this OSI model. See, a protocol is there. That protocol is created with a model, and that is called as OSI model. Okay, so this OSI model will have 7 layers, and these are the layers available. You can see our application layer, you have presentation layers, you got the session layer, you got the transport layer, you got the network layers, data link, physical layers, you got this is how. So the source, so I'm sending a message, hey, how are you? I'm sending a message to my friend. So it should cross the 7 layers. It will reach my friend and it will have the 7 layers to reach the message. Okay, I'm sending a message, hey, how are you, man? My friend Sudesh is there and he's in US. And I'm sending him, hey, how are you, man? So my 7 layers it will cross. 7 layers it will cross and it will reach the destination. It will reach my friend. And that guy is opening his computers and he can access the message. And they will have 7 layers here. And these 7 layers are called as Open System Interconnect model. And see, actually I'm sending a message to my friend Sudesh. So hi, how are you, man? So the data is there, and in this data there is an encapsulation of the TCP will be added, and here IP will be added. Over here the Ethernet data will be added, and this data will become zeros and ones here, and the communication is happening. Over here I got this data, it is removed. The Ethernet content is removed. Okay, so removed. Over here the IP is removed. Over here the TCP is removed. The next level TCP is removed. Now you got the data, and this data adding of lot of informations with the data while transferring via the medium is called as encapsulation, whereas like removing all those stuffs, the stuffing data and retrieving the original data, that is called as like a decapsulation. Okay, so this is how the communication is happening. Okay, so in each and every portion there is something, some data is appending. You can see it now. You got the data here. You can see the data here. The data is increasing here. You can see the data is increasing here. That's awesome, man. It is increasing here. Over here the data is getting reduced. You can see it here. It is getting reduced. That's awesome, man. So this is how the communication is happening, and it is called as OSI model. Okay, and the data is formatted like this. You can see the data once again. Now once it's reached the transport layer, you got some data added. So encapsulation is like adding something in it, adding. So appending some informations for the network identification. So you can see the data is running here, and you can see the data here. So you can see the data here. It is like a de-encapsulation is happening in the receiving end. Removed. Finally, my friend will get the data here. So this is how the communication is happening among the sender and the receiver. Yes, the same thing I'm trying to show you. This guy is sending a message. Yeah, the sender is sending a message to the receiver end. You can see the data is there. Now encapsulation is going to happen. Now the data becomes a segment. The name of the data is called segment in the transport layer. The name of the data becomes a packet in the network layer. The name of the data become frames in the data link layer, and it will become bits, zeros and ones. Now routing via the routers, the communication. Now you got the data. Now it becomes the bits becomes the frames, frame becomes packets, and packets become the segments. And yeah, now I got the data. It's coming back. So this is how the data communication is happening. Okay, at each and every layer, the data it's changing, man. That's awesome. This is how the data is converted via this OSI model. The segment becomes a package. The packet becomes a frame. The frames becomes bits, zeros and ones. It becomes zeros and ones, and it will move via the routers. Now bits become frames, and the frames become packets, and the packets become segments, and the segment becomes data, and the data will be received by the application layer. So this is how the sender and receiver will be communicating. Okay, so for the quick remembrance, I got a simple idea so A stands for all, P stands for people, stands for presentation, SIEM stands for session, 2 for transport, need for network, data for data link, and processing of physical. So all people seem to need data processing. A quick remembrance. And now I'm talking about the TCP. So sir, OSI model is okay, sir. What is a TCP IP model, sir? So to create your TCP IP protocol, we need a model. The 7 layers, among that these 3 layers are merged. These 3 layers are merged to become an application, and this will become the transport, and the network become internet, and these 2 merge as a network interface. So the 7 layers are merged as a 4 layer in TCP IP. Okay, that's how. Yes, I need to talk about the IP addresses before going ahead with my OSI layers and everything. So here is the one. See, I got my computers, and these 2 computers needs to communicate via a router, and router is a network layer device. I told you. The router is used as a network layer device to send the data as packets. Okay, so here is the source and here is the destination. I need to send it. For that, we need a number, a 4-digit number that is called as IP address. And this IP address is 4 numbers with a dot in it. And the total is 32 bits and 1 byte. Everything is 1 byte. It's equal to 8 bits. Okay, so the communication via the router is happened with this network layer, and the data in the format of packets. Whereas if you talk about the IP addresses, so there are 5 different types of IP address available: A, B, C, D, E. If the first number within 1 to 126 is class A, and in these 4 numbers, this will indicate the network ID, and the rest is called host ID. I'll tell you all these details in my course, in my networking course. Don't worry. Okay, so feel free to contact me. I'm ready to help you. And here is the subnet mask. 255 indicates network, the network, and the 00 indicates host. I'll talk about the subnet mask in my future videos. Don't worry. Okay, so if the first number, so this is a very important interview question. If the first number is between these numbers, then it's called class B, and this one is class B because 172 comes here, class B, and it will have these 2 for network and these 2 for host. And if this number starts with this in between this range, the first 3 numbers are network and 1 is host. Three is network and the other is host. And this, if the number starts with this one, it is used for multicasting. So you got the Sun TV, Raj TV and everything, they will have this multicasting. And finally your E, if the numbers start with the 240 to 255, it is used for experimental, NASA, ISRO, they are using these numbers. Anyway, like here is the MAC address. A MAC address is nothing but a media access control address. Every network interface card, so this one is an onboard NIC. Every network interface card will have the MAC address to identify this is the unique number in the world which is given to your computer to access the internet. So using this one, the people like the cybercrime people will identify the hackers. Okay, this MAC address is very, very important, and this MAC address is of this number. It is a 48-bit number. It's a 48-bit number. Okay, and you got the switch here. The switch is a data link layer device, and the data will be transferred in the format of frames. So with the MAC layers, the computers are identified and the data is transferred. So this is how the communication is happening. Let's move on to the next thing. Yes, so before going ahead, about the OSI models in depth, I want to share you great news. If you people are searching for a job, if you didn't get a job, don't worry. Like Kashiv Infotech, our company, we are guiding you to get your job. Okay, so we are providing internships, a job-oriented training program. So Kashiv Infotech, we are with you. Do not worry, and you can contact me at any time. Let's talk about in depth on this OSI layers, the open system interconnect layers. What is it, man? So let's move on to see it. So the first one is, like as I told you, it is called as an application layer. Application layer in the sense the user is accessing something and he is sending a message to the person, so to the destination. So my name is Venkat. I'm sending an image to my friend. So via an I'm sending access via a Facebook or something. I'm sending a message or a picture. That is your application layer. So obviously you'll be using HTTP protocol to chat with them, to browse a website, to send a file FTP, or to send a mail, it's SMTP, simple mail transfer protocol. A hypertext transfer protocol, file transfer protocol, simple mail transfer protocol. So that is your application layer. Via a website, I'm trying to access a Facebook. I'm loading a page, loading a file using FTP, or I'm sending a message using SMTP, and this is called as application layer. So you're setting a browsing center, accessing your Facebook. Now I got the image sent, but via the network, the image is encrypted, converted into a different format. How the presenting is happening. So whatever the data is, it is converted into a different format. So it can be a JPEG or GIF images or MPEG images. So converting your format into another format. Okay, that is done in this presentation layer. Okay, that is called as presentation layer. And maintaining a session among the user. See, my name is Venkat. I logged in, my inbox is coming. I can see my inbox, man. I need my sent item. My sent item is coming. I need my draft. How come my Gmail knows it is my, it is Venkat? So they will maintain a session. Session is nothing but an identification token. Okay, so hey Venkat, this is a token for you, man. So show me the token. A token is in. Yeah, this is Venkat. So the token is between the server and the client. Okay, and this token is very, very important. So this is Venkat. For him, this is the message. This is for Jayant. This is the message. This is for Krishu. It is the message. This is for Sudesh. This is the message for each dedicated people. So to whom what we need to give, that is defined by this session layer. For example, it's Apple Talk and Winsock is an example. And these three layers are considered as upper layers. So it's in the computer. So the application layer, my browser is there, converting is done, and the maintaining session, everything is done. Now it is transferring via the wires. So obviously this is your lower layer where your network devices comes into the picture. So let's move on to the transport layer. So over here, the communication, so how I'm sending the data. So I got my router, and this needs to be connected. So obviously, like I got my LAN cable. So I got my LAN cable. So this is my LAN cable. So this is my LAN cable. It is connected now. Yeah, it's connected. So it is a connection oriented. If it is connection oriented, it is called TCP. It is called TCP. So I got my mobile. And my mobile is connected to my Wi-Fi router. This is my Wi-Fi router. So I got my mobile here. So the communication is wireless. There is no wireless. So there is no wires. That is called UDP. So if it is wired, that is called TCP. And if it is wireless, and it is called UDP. You got your TCP. How the communication is happening? You got the wired environment or you got the wireless environment. Somehow the communication is happening. So it's TCP, UDP, SPX are there, and we should think about this one. The very important features. So the features which we need to consider are error handling, error recovery. If there is any error, how you are going to recover from it, how you are maintaining the flow of data, and how we are going to support the retransmission. If there is any error occurred, I want to retransmit the data. So in that case, how we are going to retransmit the data. So that is how your transport layer works. Now let's move on to an interesting part, your network layer, where your router comes into the picture, and these are routers. So your routers comes into the picture. So this router, so obviously you got the router here, so it will take care of your IP, ICMP, IPX and everything. So to which path, through which path the data should move. So this is the right path, man, which is the shortest path, and to whom, exactly to whom we need to send the data. Everything can be defined by this router, and it comes in the network layer. And the next layer is your switches, and this is your switch, and this is your switch. Okay, the switch is nothing but, so the switch will have, this is nothing but based on the MAC address and also the IP address, the data will get transferred. So in the router, it will be using IP address, and the switch will be using your MAC address. So every computers will have the MAC address here. Okay, so you are able to see an IC here. You can see the IC here, and this IC will be taking care of getting. So this is an onboard network interface card. So you will have, every computer will have a network interface card, and this network interface card will have a MAC address, and this MAC address will be matched with this switches to form a LAN, local area network. So that is called as media access control, media access control. So via this one, it will identify what is the source and what is the destination, and they will try to send the data in the form of frames. So switches and bridges are typical examples. And finally, here comes your physical layer, where you got your wires here, and this is your wires, and this is your wires. So the data is communicated via this kind of wires, and this is called as physical layer. Physical layers. Yes. Now we'll talk about more on this physical layer further, don't worry. So here is the 7 layers which we discussed. So the user is accessing an application, HTTP, and the data is converting and encrypting. That is your presentation layers. From there, the session is maintained between the users. So to Venkat, only the data should go to only to Venkat, not to others. Okay, and over here we got the communication can be connection oriented or connectionless. Connection oriented is called TCP, connectionless is called UDP. And now we got the data, so you got the IP address to identify your computer. So obviously to the destination the data should go, it should not go to others. So over here you got the network layer, where the IP address is identified with the help of routers. They will try to send the data. And the next one is the frames, where the communication is happening via the switches. And you got the MAC addresses for that. Okay, and finally via the wires the communication is happening. Okay, these are the 7 layers which will be used to create your protocols. Now let's talk about the physical layer, that is your transmission medium, how the data is communicated via the wires. So that is the one we are going to see it here. The transmission can be happened via the guided media like a twisted pair cable, coaxial cable, fiber optic cables, and unguided media. So this is the guided. Via this wire, send the data. So my mobile is there. How come it is communicating with my Wi-Fi? No guidance. Via the air it's happening. So the guided and non-guided, unguided area. So you got the twisted pair cable, coaxial, fiber optics, and here radio, microwave, and satellite. We talk about the medium factors, like what are the very important factors we should think while sending the data. So the bandwidth, how much bandwidth you are sending the data. So a higher bandwidth will give higher data rate. While taking my internet connection, I used to ask, like, what is the bandwidth, sir? So it's 10 Mbps, sir. It's 100 Mbps, sir. Okay, bandwidth is very, very important for transmitting the data. I want to download the film. What is the bandwidth, man? The film is downloading very slow. So the bandwidth is very, very important. Transmission impairment. So if there is any problem, so that the data is lost. The data is lost. The transmission impairment is very, very important. We should consider. We should be really careful. Interference. Sir, I'm sending this data, sir. And this is interacting with this data, sir. Problem, sir. Because like interface is happening, interference is happening, sir. And it's a problem. We should be really careful. And how many receivers are taking the data? To only one people, Superman. Sir, to 100 people, so 1,000 people, sir, very tough, man. We need a high-end devices, man. Because 1,000 people should receive my data, sir. Okay, so unicast, one sender to one receiver. Multi-class, multi-receivers can introduce more errors. So we should be really careful. These are the very, very important factors you should consider while transmitting the data via the medium. So if we talk about the impairment, what is a problem, sir? Sir, I'm sending the data, sir. What is the problem? Obviously, I told you everything. Attenuation and everything is there. Let's see, like, what are the problems, impairment happening here? Okay, so the transmission medium impairments, attenuation, you are able to see it here. You got the signal here, and this is some other signals are getting added, and it is, you are able to like amplify the signal. While sending the signal, it will become weakened. While sending the signal, it will become weak and loss of energy. So we have to amplify it to make the signal effective. The attenuation is like loss of energy. And the second thing is a distortion. Distortion in the sense, I want to send a composite signal, sir. I want to send a signal, sir. In that case, the signal changed from its original form. You can see the signal. This is the original signal. It will become like this. The composite signal contains different frequencies. Each has its own speed and delay. Sir, I want to send multiple signals at a shot, sir. Then there is a problem. There is a problem and confusion happened because of multiple signals merged. Okay, that is called as distortion. And maybe a noise, adding of additional things which will disturb the signal. Okay, so these are the very, very important factors and impairment you should consider, and you should really be careful in sending the data. Yeah, the first one is like, I'm going to talk about this twisted pair cable. This twisted pair cable. If we talk about this twisted pair cable, you are able to see some colors here. You are able to see some colors here. Yes. So you are able to see some colors here, and these colors are really important. Okay, so you are able, so these colors, so it is divided into two different things. One is called a shielded. So you can see the shield here. So the cables will have 4 pairs. The cable will have 4 pairs. You have blue, brown, orange, green. And there is a whitish green, whitish orange, whitish brown, and whitish blue. You got 8 wires combined. On top of it, if you got a shield, that is called a shielded twisted pair. And sir, I don't have any shield and all, sir. That is called as unshielded twisted pair. This doesn't have any shield and all. Normal. It is an unshielded twisted pair, and you can see the colors here. Okay, and you can, like, if I cut this one, I can show you like 8 wires inside it, and these wires are very, very important. 8 wires. Okay, so the cost not very high. The advantage and disadvantage I'm talking about for shielded too. So cost is not high. Installation of STP is easy. Higher capacity when compared to, so this got the higher capacity because the dissipation of signals is lesser, because this is shielded, man, so the signal won't go out. So it has a higher attenuation. It is shielded, so higher data transmission rate. So everything is good here. And but the disadvantage is expensive. So the it has a higher attenuation rate is good. So but still it is a problem also. And here is the categories. So if you talk about the categories of this twisted pair cables, category 1 support low speed data, category 2 up to 4 Mbps, category 3 16. So if you go to a shop, you can ask me, sir, I want a twisted pair cable, sir, which category you want? Category 4. Oh, you want to support 20 Mbps speed? Up to 20 Mbps speed, you can have to go this one. So what wires you are going to use, it is very, very important. So if you want to transmit almost 100 Mbps to 200 Mbps, you should use a category 5 cable. Then only it will be fast. Cables will be differing. Yes, this cable is too fast cables. This cable is too fast cables when compared to this cable. This cable, a normal cable. This one is a normal cable. You can see in your colleges and all. Okay, so the cables will differ. The cables will differ. Okay, so you should be really careful. So unshielded twisted pair. This is your unshielded twisted pair. Okay, so this cable can be used with a shorter distance because of attenuation. Cheaper. Installation is easy, and for high-speed LAN also you can use it. So that is the one for the twisted pair cables. Now let's talk about the coaxial cable. Sir, I got my TV connection, sir. So for the TV and all, you will have the cable, right? TV cables is called as coaxial cable. It will have an inner conductor, an insulator, an outer conductor, an insulator, and a plastic cover. Okay, so you got the conductor here, insulator here, insulator or plastic here. Okay, so types of coaxial cables are baseband and broadband. Very small single signal, baseband. Multiple signals, broadband. So category is called, the category is like RG59 for radio TV, RG58 for thin internet, RG11 for thick internet. Okay, these are the categories. Okay, so TV wire is usually a coaxial cable. Contains 2 conductors parallel to each other. Okay, the advantage is like obviously transmitting is good, better shielding, higher bandwidth. So over here the disadvantage is it's more expensive. Okay, if any fault is happened in the mid of the wires, then we have to change the entire wires. That is a problem. So this is for coaxial cable. The next one is like your fiber optic cable. Yeah, this is your fiber optic cable. This is your fiber optic cable. You can see the fiber optic cable. This is your fiber optic cable. This is the one. You can see the fiber optic cables like this. Okay, so fiber optic cables, so the transmitting the data as in the kind of a light signals is called as fiber optics. So it will have the core layer in the mid, and on top of it you will be having a cladding layer. So you'll be having a core partition inside it with the cladding layer outside. You are seeing the cladding layer here with the outer jacket. So you got the core layer here, cladding layer here, coating, strengthening. So you need little bit of strength. Strengthening layers. On top of it, you got the plastic shield like this. Okay, this is your optical fibers. So that the data will be transferred in the format of light signals. So the light speed is very, very faster. So obviously you are able to almost, it's a 3 lakh meters per second, more than that. Yes. Okay, so almost 3 lakh meters per second, more than that. Okay, so you got the speed is 100 plus Mbps speed you are able to achieve. So, but it's most expensive, and the median connector size is very, very small. The maximum cable length is 2 kilometers. You can able to generate a 2 kilometers cable. So single mode and multi mode is there. So single mode is there with a laser, and multi mode with the LED generator light. Okay, this is how. So transferring the data as like as in the form of light signals is called as like fiber optic cables. The core part is created with silica, and the cladding part is once again with the silica. On top of it, you got silicone coating, you got the buffer jacket, and this is your optical fiber. You got the strengthened materials, and you got your black polyurethane outer jacket. This is it is resistant to little bit of heat energy. So if I burn it, so it will take some time to burn. A little bit of safeguarding is there. Okay, this is your fiber optic cables. Yes, so fiber optic cable, like this is your single mode. Over here in the single mode, you will be having a single line to communicate. Okay, and your core layer will be of size 9 micrometer, and the cladding layer of size 50 micrometer. Okay, that much small size. This is your single mode. Whereas the multi mode will be having the data, the multi signals will be transferring like this. Okay, that is, it doesn't have any like uniformity. Whereas multi mode step index doesn't have any uniformity. Whereas the multi-mode grade index will have a uniformity like this. So you are able to see there is no merging here. There is a merging of data is happening here. Merging of data is happening in the destination. Okay, this is a segregation in like a fiber optic single mode. In multi-mode, you got a multi-mode step index and grade index. Now let's talk about the unguided medium. The one is like microwave. Unguided medium, we already talked about microwaves, radio waves, and infrared. Before that, we should understand the signals here. You got the gamma rays here. You can see the frequency is more here, and frequency is getting reduced here. You got X-rays, ultraviolet, visible light, infrared. You got the microwaves here. The microwave oven to to create your snacks and everything, burgers and everything. You're a microwave oven, right? So microwaves for cooking and snacks. And please note down all these things because it is used in interviews. Okay, so microwave signals. Why are the microwave signals? The communication is happening. Okay, and that's how. Okay, if you talk about microwave signals, the communication is happening, and it is happening via the so communication is happening, and the type is like it is called as terrestrial microwave. You got the like towers kind of to transfer the microwaves. It's like a point to point. And if it is so via the towers, if it is done, it is called terrestrial. Via the satellite, if it is used, it is called a satellite microwave. So microwaves are of two types. One is terrestrial, the other one is satellite. And this is called as transmitting, and the other one is a receiving station. Okay, so transferring the data via the microwave concepts is called as a microwave unguided medium. Again, it's of two types. We talk about satellite way of communication. You got the satellite, the center guy is called a transponder, satellite transponder. You got the uplink the station, and you got the downlink station. So sender and it's a receiver. It got a lot of flexibility, and really like nowadays satellite is the mostly important one which people are using for communications, for broadcasting the messages and TV programs, everything. Okay, and we got the other one called radio signals. So via the antennas, You got the transmitting antennas, you got the receiving antennas. And the frequency range is almost 4 to 6 GHz to 21 to 23 GHz. And the electromagnetic waves is transmitted between these two people. And we are, so radio, obviously radio, to everyone, broadcasting. So multicasting, and it can be broadcasting. Omnidirectional, to any direction you can do it. And the frequency of radio waves is 3 kilohertz to 1 kilohertz. Okay, this is how the things are. And finally, like there is another thing called infrared. So I got my remote. I got my remote mobile. Like I got my remote. So I'm pressing this one. I'm able to like send an infrared to my TV. So signal or data is communicating between the TV and the like a remote. So that's your infrared. You can see it here. This is your infrared for it's my AC remote. You can see the infrared here. Okay, so it is very, very low. So like I don't show you. Yeah, it's there. We are able to see it here. You can see the infrared here. Ah! Even I didn't notice it. Have you seen it? You can see it here. Yeah, it's there. So, but from a human eye, I couldn't see this one. That's awesome, man. Anyway, like yeah, that's really good. That's really good. Anyway, so like infrared is the one. So it's a wireless technology used for communication over short ranges with the 300 GHz to 400 terahertz speed you can transfer in the short range, but too fast, very, very faster. So you can have the remote to access it. So that is your infrared. So this is how your unguided medium is working. Now let's move on to the next area called switching. Transferring the data. So this switch is there. This switch is there. And the computers are connected, the switch is there and computers are connected. How the communication is happening between the computers from here to there, from here to there. So the communication is happening to create your LAN environment. Okay, how the transferring of data is happening. Okay, so this is how. So switching technique to transfer the data, switch is a device to transfer it. So over here the switch will have the Ethernet frame. The Ethernet frame will be having, this is the one, your Ethernet frame. It will have 4 bytes. That is called a frame check sequence. This is to detect any errors occurred during the transmission. The data, actual data which you are sending. So see, actually like you got the data, right? While sending the data, so these are the things will be added. These are things to be added to safeguard the data. So what is the type of data? It's they indicate what type of data the frame is carrying. It is an image or text or whatever things, man. Okay, and you got the MAC address, the media access control address. It is a 48-bit address. This is an address. This is a kind of address. So the MAC address will be there. The destination MAC address, source MAC address. So like I'm sending a message. Yes, this is the one. I'm sending a message. Hi, I'm sending a message. My computer is here. Hi. So I want to send this one. I want to send this one to ABC. So I want to send this one to ABC. This is ABC. Okay, so I got a lot of wires. Are connected. So I got only one wire. That's what I'm telling you. Okay, so I connected this one. So I'm sending like to ABC. So source MAC address will come. FCS data type source MAC address, destination MAC address will come to the switch, and switch will try to like you got the internal programming which will identify. Oh, this is the destination, man. This is the destination. So source MAC address, destination MAC address, FCS, data, and type. Everything will come out, and this guy will receive the data. So this guy will send the data, and this guy will receive the data. So this is how your Ethernet frames are. To check whether the data is correct or not, for that we got a checking called a cyclic redundancy check, CRC. the sender, so I'm sending a data A, B, C, A, B, C. A alphabet is 1, B alphabet is 2, C alphabet is 3. 1 plus 2 plus 3 is 6. So the some value is 6. Like that, they will have some combination. You can have any logic. Any logic you can have. For typical example, I'm telling you. Sir, A is equal to 10, sir. B equal to 20, sir. C equal to 30, 60. The sum is 60. In the destination, so it will add everything. So Venkat is sending a data. Venkat is sending a data ABC with the FCS value as 6. Destination ABC is received. And it will do a manipulation. ABC 1 plus 2 plus 6. It's correct. FCS value is correct. Okay, so the cycle redundancy check is paka. So automatically the destination is okay. I'm sending ABC 1, 2, 3. ABC is 1, 2, 3 internally. The 6 FCS is 6. So here ABC, instead of ABC, I got ABD. A is equal to 1, B is equal to 2, D equal to 4. 1 plus 2 plus 4, 7. FCS is 6, but I'm getting 7. So the data is wrong. Which that is a problem. So this is how they will identify. So this is how the security is maintained in the data link layer using switches. So here is the difference between the hub and the switch. The hub is nothing but a physical layer device. It is asked in CTS. It is asked in many interview questions. Where switch is a data link layer device. The hub will send data to everyone, stupid fellow. But switch will send to the correct destination. Okay, and two types of hub is there. Interview question. Active hub, it needs electricity. It will regenerate the signals. So once if it receives the signals, it will regenerate the signals and amplify the signals and send it. It is used kind of an extender. Whereas the passive hub, it will just send the information. It doesn't do anything. Whatever is it, send it, man. It is weakened, let it be weakened. Okay, that is how your hub is. And hub will send to everyone, which will send to the correct people. So this is a brilliant device. It's a non-brilliant device. That is called physical layer, and this one is data link layer. Yes, yeah. So here is the one I want to talk about. So considering the environment is there, connecting computers to another computer, that is called as a peer-to-peer. Connecting a client to the server is called a client-server network. So you can see, so the switching is happening. So connecting without, so all computers are interconnected, man. Sending data to data and receiving data, man. So in that case, it will send to the correct people. Whereas in the client server, the server, it will send to the correct people. The client will send to the correct people, to the correct server. That is how happening. So you can see the destination. If the destination address is defined, you can see the MAC address, and exactly to the destination it will send. So this is how the switching concepts will work. Now let's talk about the switching types. So what are the types are available in switching? So if you talk about switching types, so here is the one. You got the circuit switched environment, you got the packet switched networks, you got the message switched networks, and under that you got datagrams and virtual circuit networks. These are the types of switching types available. The first one we are going to talk about the circuit switching. You can see the circuit switching here. Yes, you can see the circuit switching here. So it depends on the connectivity. The circuit is dynamically connected. You can see the connection here. So this is how the circuit switching works. So whatever network you want, automatically the circuits are interconnected. So it is connected for the communication. That is how your circuit switching works. Whatever circuits you want, based on that the connectivity will be happened. Okay, that's how your circuit switching works. We talk about the packet switching. Which packet, so which direction the packet should send shortest path to reach the destination. So dynamically matching the network, to do it, that is called circuit switching. The network is there, man. which is the shortest distance to reach the destination, which is the shortest path I can go. That is what packet switching environment. So this is how your circuit switch channels and packet switch channels are. And if you talk about the message versus packet switching, so as I told you, packet switching, so we got 3-1 circuit and packet we have seen. Now we are going to talk about packet and message. Sending the entire data at a shot is called as message. Separating the data and sending it as separate packets is called. That is the difference. Now final thing, datagram versus virtual circuits. So if you got the datagram networks, so like the data is sent randomly. Two packets of the same user can travel along different routes. So Venkat is there here. Venkat is sending two data. I'm sending data to one of my friend Krishu and the other friend is Jayant. I'm sending data. Krishu and Jayant, I'm sending the data. While sending this data to two people, I'm sending the data with a different path. It can go and reach the destination, man. That's awesome, man. So that is how your datagram network will be. Whereas in the virtual circuit network, it should travel in the same path. Both people are in different places, man. This guy is in Chennai and that guy is in America. Same path it will travel. All packets of the same virtual circuit travel along the same path. The packets can arrive out of sequence. Okay, the packets contain the source address and everything, destination, everything is there. Okay, so this is how your datagram over here. Everything is going in the same direction. So the packet contains the short virtual circuit network ID. Packet sequencing is guaranteed because this guy will travel a different path. I'm calling, hey, have you received? This guy received, but this guy didn't receive, but it's a different path, man. Whereas here, the same path will receive the data properly. That is the differences between the datagram and the virtual circuit. See, if two data is there, if it goes in the same direction, virtual. If it is going in the different direction and reach, that is your datagram network. Simple. Okay, like it's a final recap, final touch of our OSI model. I'll close my session today. Hope you enjoy my session. Yeah. So over here, this is the final wrap up of things. So you got the 7 layers over here. These layers are used to create your protocols, end user. You got the program to open the Facebook, LinkedIn, Twitter, the encryption, decryptions. You got the logical ports and everything, and you got your flow control. You like for example TCP and UDP, IP address, MAC address, cables and hubs. We talk about the defense model. Okay, so defense model is contains process, host to host, internet, and okay. So this is how the entire data structure will be. Just keep a note on it. Learn as much as you can from this. And here's my Instagram account to follow me, and I'll give my contact numbers to contact me. For any help, you can contact me. And our company, Kashin Photog, we are trying to give a lot of things. Looking for networking course, internships or projects, you can contact me via my website, my contact numbers. We got internships, courses, in plant training, anything, you just contact us. We are ready to help you. Okay, treat me as a brother. So not only to learn courses, you can contact me at any time for anything. And we got our online internships via mykashi.com. We got offline internships also at my Chennai office. It's time for me to say goodbye to you. I request you people to share my videos and these things to your friends and everyone. Let's help others and let's grow the society. And this is Venkat signing off from Wikitech and Kashin for. Thank you. And here is my list of courses. If you're really interested, contact me, man. I'm ready to help you. Ta-da, bye.